so that anytime t is greater than 0, okay, they give you the velocity and they're asking you for the acceleration at time 4. Do you understand that the acceleration is the derivative of velocity? Okay, so if they give you velocity and they ask you to take the derivative and plug it into 4, plug 4 into it, do you know a shortcut for it? The calculator. Okay, so you'll have a problem like this on the test. Make sure you can just put it into the calculator and get the right answer. Okay, so if they give you velocity and ask you for acceleration, or if they give you position and ask you for velocity, right? If it's a derivative, then you can go straight to your calculator. Okay, I'm gonna reset my calculator. So how do you reset your calculator? I just had a second memory. Thank you. Just had a brain fart. Okay, so right here, I'm going to do math 8. Okay, I'm going to put d dx right here. Okay, d dx. Right here, I'm going to put my function, which is 3 plus 4.1 cosine of 0.9. I know it says t, but I'm going to put x. My calculator doesn't know. I'm cheating on it. Shh. All right, instead of t, I'll use x, and x is going to be 4. Press enter. And this is what I get, 1.632 or 1.633. I can truncate.
How did you get the derivative thing? What did you press?
Math 8. Okay. Does anyone have an older calculator? Do you have an older calculator? Okay. Let me, I think I can open up an older calculator. Let me go here. No. Yeah. Ooh, look how small that is, though.
Pretty much.
No.
What if it uses E?
You just put an E, just like it says E. You just punch it right into the calculator like that. Ooh, look, I have 2 of these. I don't know why I have 2 of these. Okay, I don't know why I have 2 of these calculators. Okay, but let me, let's go to the old calculator. Okay, if you go to the old calculator, let me clear my screen here, second quit. Okay, what you would do is you hit math 8. Okay, you have inderiv. You would put your function in that. What's your function? Is it 3 plus 4.1 cosine 1.9? Oh, just 0.9? Okay, so 0.9 x, close your parentheses, okay, because that's the parentheses on the cosine, and then put a comma, okay, then you'll put x, okay, then you'll put a comma, and then you put what you want to plug in. So you want to plug in a 4, okay, then close your parentheses. That's your big parentheses. Always pray, hit enter, and then you'll get the right answer, okay? I'm serious. Sometimes you don't pray, you don't get the right answer, and you're like, what did I do wrong, okay?
Ms. Chang, whenever I put E in it always gives me 0. I don't know what I'm doing
are you doing the one on your homework?
Yes.
Okay, so let me pull out the homework. So on the homework, it's number, what number is it? Is it number 9? Okay, let's go. Do you have the old calculator, Andrew, or the new calculator?
New one. I have a new one.
Okay, so you must be richer than Paula. Okay, so here we are.
Correct, Paula. Loser.
Math 8. Okay, so you're going to put an X here. Okay, right here, you're going to put in your function. Is your function, well, tell me what your function is, because it's probably different from ours.
It's 4 plus e to the 3rd.
Okay.
Or to the 1/3, yeah.
4 plus, okay, I'm going to do this second e, this ln right here. Okay, and then in up here, are you putting one? Are you putting,
I read the wrong e.
Okay, yeah, do this e here. So then you'll put x divided by 3. I think that's what you have, right?
And then, I have 1/3.
No, it should be t over.
Oh, it's a t.
Yeah, it's a t.
I can't read.
Yeah, it's a t.
That makes so much more sense now.
Yeah. And then you're going to put in the number.
I just can't read.
No, it's okay. I did 1 before 2. Okay, so if
you're... Ooh, it works.
Okay, so did you get the same thing I got, Andrew? Yes, no?
Sure, yeah. Well, my time is 7, but close enough.
Oh, your time was 7. Okay, sorry about that. Okay, yes.
Close enough.
All right, let's go ahead. That, guys, is on your test, and I want to go ahead and move to number 8 on your review. Let's do number 8 on your review together. This is also on your test. But I didn't copy it here, so mine won't have your problem, but it'll basically be the same thing.
That looks like a long
Okay.
problem.
You guys did this already. You've done this problem. It's almost the exact problem you guys had on your test. Okay. So the position function is t cubed
Question
minus
8.
12t squared plus 45t. And those of you guys at home, yours is going to be a little bit
Find the
different.
velocity function.
Did you say the Pulowski
Oh,
function?
what the heck? I'm unmuted.
Okay.
That's not right.
Okay. I actually agree with you right now, Andrew. Okay, so position function right there. The velocity function is 3t squared minus 24t plus 45, right? And the acceleration, I know I'm not asked for it, but I think I'm going to use it anyway. So go ahead and find the acceleration. All right, so we've done part A. Let's go ahead and do part B. Part B says, what is the time when the object is at rest?
Time and 30.
Very good. How did you get that? What did you set equal to 0? Yeah, you set velocity equal to 0. And this is the, oh, I thought he was playing baseball.
Oh, he's playing baseball. Yeah. So actually, he just called me from the tournament.
Okay, got it. Okay, got it. I thought it was going to be an excused absence. Okay. All right, so this is velocity is equal to 0. Everybody good with time, with being at rest means velocity is equal to 0? It's one of these is equal to 0. It's either position, velocity, or acceleration, okay? So particle at rest means velocity is equal to 0. Set velocity equal to 0 and solve for your time. It's easier to pull out the 3 first, okay? And then see if you can factor this in order to solve this. I think it's a 3 and 5? I think 3 and 5 will work. All right. So what I get is something times something times something equals 0. What does that mean about one of these somethings? Okay. It means either 3 is equal to 0. Oh, that's silly. 3 cannot be equal to 0. Or t minus 3 is equal to 0. That's possible. Or t minus 5 is equal to 0. That's possible. So what this tells me is that the 2 times when my particle is at rest, or meaning when velocity is equal to 0, is 3 and 5. Guys, make sure you understand this. This does not mean when my velocity is at a minimum. Okay, velocity at 0 does not mean velocity is at a minimum. Because if I go look at my velocity graph, which I'm going to have to anyway, so let me just go ahead and look at it. Let me put in my velocity graph right here into your y1. And you can do it because you're going to need to do this anyway. If I put 3x squared minus 24x plus 45, and I graph this, okay? My velocity is 0. Do you guys see at time 3 and 5? Let me use my mouse. Say time 3 and time 5, my velocity is 0. But is that when my velocity is at a minimum? When is my velocity at a minimum? You can see actually, it's when time is equal to what? 1, 2, 3, 4, at 4, between 3 and 5. Do you see that?
Yeah.
That's the minimum is my lowest velocity. So a lot of students are telling me velocity as a minimum means velocity is 0, but no, that's not what it means, okay? Velocity at minimum means the velocity is the lowest it can be, even including negative. All right, when am I moving to the right? So when is the particle moving to the right? Well, what is velocity when you're moving to the right? Do you remember? Velocity is positive when you're moving to the right. What is velocity when you're moving to the left? Velocity is negative when you're moving to the left. So look at your picture, okay? This is velocity, right? So when is my velocity positive? Okay, so let me just do a number line. Maybe that will be helpful. Okay, this is my velocity number line. Velocity is 0 at 2 points, 3 and 5. Okay, when is my velocity positive? To the left of 3, am I positive or negative? Positive, meaning above the x-axis, right? Isn't that what positive means? And when is my velocity negative? What about between 3 and 5? Am I above or below the x-axis? Below, so that's velocity is negative.
When velocity is positive, you're going down.
Not going down or going up. Positive means above the x-axis. Negative means below the x-axis. So this is
negative, you're going left, right?
Oh yeah, I see what you're saying. I'm not quite there. You're faster than me. So this is positive, okay? Guys, if this is V, okay, then if V is positive, okay, remember V is really X prime, right? So if this is F prime, then this is F. If this is X prime, then this is a picture of X. Then position is increasing, position is decreasing, and position is increasing. Do you guys see? If this is a picture of V, if the number line is V, then the picture has to be X, okay? So if this is X, then when am I going left? When X is going decreasing. Does that make sense? Remember, X, guys, is just the numbers on this number line. Okay, there's a number line here with numbers. Okay, when the numbers go up, okay, wouldn't I be going right? Right? And when the numbers go down, wouldn't I be going left? Does that make sense to you guys? Okay, so here the numbers are going up. Okay, and so just like the COVID numbers. Okay, so this is going to be going right. So this is going to be going right. This is going to be going left. And this is going to be going right. Okay, so let's answer the question. You guys can circle it, circle the correct ones. When am I moving right, guys? Between what? 0 and 3, and what else? And 5 and 7. Okay, so this is going right. And guys, when am I going left? 3 and 5. All right, next question. When am I experiencing minimum velocity? We already talked about that. When am I experiencing minimum velocity? Look at your picture. Okay, very good, 4 seconds. And actually, guys, if you wanted to calculate that, the way you would calculate that is you would say, let me write this down. Okay, remember, if you went to your picture, you would have a picture that looked like this. Okay, and this is your velocity graph. Okay, if you really wanted to know what this is, and let's say it's a fraction, it's hard to figure out. The way you figure out the time at this point, well, if this is your V graph, isn't this when V prime is equal to 0? Right? And so V prime is equal to 0. That's just your A is equal to 0. Okay. And we know our A is actually 6t minus 24. Okay. If you go look, you wrote that somewhere at the top of your paper. Okay. And so when A is equal to 0, guess what 6t is? 24. Guess what t is? 4. Okay. So your derivative here is equal to 0 at your minimum velocity, which is when time is 4. The next question I ask you, though, is what is a velocity? What is a minimum velocity? It happens when time is 4. But what is that velocity number? How do you get that velocity number? You plug it into which equation? Velocity, okay? So go to your velocity equation, which is right here. Here's your velocity equation, your y equals, right? And plug in 4. So there's lots of ways to do it, but I think one of the easiest ways is just to do alpha trace and pull up your y1 because my velocity is already in y1, and then plug in 4 into your y1. Okay, so your answer is -3. What if I ask you the speed? What's the speed at that time? 3, exactly. The speed is just the absolute value of velocity. Okay, some of you guys might have gone to your table, and I think that would have worked too. If you went to your table and looked up 4, does that make sense? You could also see that your velocity is -3. Okay, next question. What is the velocity when time is 1? And what's the acceleration when time is 1? Okay, guys, look at this table. What's the velocity when time is 1? Isn't this my velocity graph? Yeah, so what is it? 24. Do you guys see that? And then what's the acceleration when time is 1? I don't have my acceleration formula in here, but I mean, I could make it. Isn't it 6t minus 24? So I can do 6t minus 24. That's my acceleration graph. Go ahead and hit second table. And I can also read off my acceleration when time is 1. And what is it? -18. Do you see how easy this is? It is easy, especially when I'm up here doing it with you. Okay, when is the particle speeding up? Guys, speeding up and slowing down, which curve do you look at? The position, velocity, or acceleration? Velocity. Guys, I already have the velocity. No, not for speeding up and slowing down. So I'm gonna toggle on my acceleration, how it has that black box on it. I'm just gonna toggle it. I'll push enter on it. What happens is that black box goes away. What that does is that hides y2. Y2 is hidden now. So when I graph, all it does is graph y1. Okay, it's like hiding the equation. So this is my velocity graph, okay? So tell me, always go left or right, guys, okay? Follow your finger down. And when am I speeding up and when am I slowing down? So guys, slowing down or speeding up right now? Slowing down, okay? Until I hit what number here? Is that t equals 2? No, t equals 3. Okay, so I'm gonna write this here. Slowing down for, I'll say from 0 to time 3. Okay, from time 3 to time 4, slowing down or speeding up, guys? Speeding up, okay, it's all right, speeding up. 3 to 4, all right. Guys, from time 4 to time 5, speeding up or slowing down? Slowing down, so I'll say 4 to 5. And then finally, guys, from time 5 and on, speeding up or slowing down? Speeding up. And I think our limits here are 7, so I'll do 5 to 7. If you do 5 to infinity, I know what you're talking about. I'll still count it right, okay? All right. The slowing down, though, guys, you need to know the justification. The justification that we just used is because the velocity is going closer to the t-axis. Do you agree with that? That's how you knew, right, that we were slowing down. But do you remember the other justification for slowing down? Because velocity and acceleration, when do you slow down? When velocity and acceleration have the same signs or different signs? When do I slow down? Different signs. When the wind is blowing against me, right? So different signs. When velocity and acceleration have different signs. I know I missed the word have there, okay? Don't sweat it. I'm just looking for certain keywords, all right? And that's totally fine. All right, speeding up. What we did in our graph, we were looking at when velocity is going further away or going further from the t-axis. This English is so bad, but you guys get my drift, okay? What's a better way to say that? When velocity is going further away from the x-axis? Okay, you guys aren't helping me, and I'm on my own here, and I'm an immigrant, so hey, okay. Because another reason would be velocity and acceleration have what guys? Same signs.
That's the justification.
That is the justification. Oh, that's one on your paper?
Yeah.
Okay, good. And that's going to be the one on your test too. Okay, next question then. The acceleration, find that when the velocity is 0. Guys, if they ask you for the acceleration, okay? If they ask you for the acceleration, write the acceleration formula. Okay, if they ask you for acceleration, there's no other way to get it except to know the acceleration formula. Okay, now they're saying, figure out what the acceleration is, solve for A, okay? But you can only solve for A if you know what letter. T, right? If I can plug in the T, I'll know what A is. So all you do is you ask yourself, okay, what T do I plug in? When is velocity 0? Okay, guys, can you put your phones away, please? When is velocity 0? Okay, 3 and 5. So first you're just going to plug in 3, and then you're going to plug in 5, okay, and find what that is. So it's 6 times 3 minus 24, and also 6 times 5 minus 24. This is 18 minus 24, which I believe is negative 6. This is 30 minus 24, which is positive 6. You've done this on your test before. Did you notice if you got both of them right, that one was just the negative of the other? Okay, and it's going to be like that on your test tomorrow too. Okay, and that just happens when you have this parabola, this type of parabola going on. Okay, it's not true all the time, just FYI. It's just a type of problem I'm giving you. Okay, and then finally, total distance. I usually give you, and I'll give you the table for total distance, okay? And really, you just have to fill out the table. When you see a table, you should be thinking already, candidate's test. Okay, that's what you should be thinking. So what goes on a candidate's test? What goes on the left side here, guys? 2 things. The endpoints, what are my endpoints here? 0 and 7. And the critical points. Okay, with this is x, okay, like if this is f, I would take f prime and set equal to 0. So this is x. What am I going to set equal to 0? X prime. You guys good with that? Set equal to 0. So guys, if I set x prime equal to 0, guys, what's another word for x prime? Velocity. So when I set velocity equal to 0, what times did I get? I did that somewhere. I think I did that in part B or something. What, 3 and 5. So those guys are going to be my critical values or my critical points there. 3 and 5. And then I just need to fill out this side. Well, guys, if I know my t's, how do I get my x's? Like some students will ask me, should I put velocity here or position or acceleration? Guys, what is this letter here? X, right? It's position. So you need to go find your position formula. So I'm going to go back to my calculator, okay? And this time, instead of velocity, I'm going to put in my position formula. I'm going to go ahead and clear velocity from here because I actually don't need it anymore. So I'm just going to clear both my velocity formula and my acceleration. Okay, and put in my position formula here. And I'm going to create a table. I think it's easiest just to create a table here. So this will be x cubed, all right, minus 12x squared plus 45x. Okay, that's my position formula. And I'm just going to copy that table. Do you remember how to make a table? Second table set. Okay, change your auto to ask. Okay, then go to second table and then just fill in your table and it'll duplicate that table over there. So I'm going to put 0, enter, 3, enter, 5, enter, 7, enter, and you just copy those numbers. You almost feel bad doing this, right? I mean, I know you feel bad but for other reasons. But you feel bad because like the answer is right here, 0, you just copy it, 54, 50, and 70. Okay, but those aren't my total distances. Do you remember how to get total distances? Okay, if I'm at 0 on the number line and I go to 54 on my number line, what total distance did I travel? 54. If I'm at 54 on my number line and I walk to number 50 on my number line, what total distance did I travel? 4. What about between 50 and 70? 20. Add all these numbers together, guys, okay? And that is your total distance, all right? The last thing they ask you for is displacement, okay? And if you have your table already, displacement really is, see if this makes sense, it really is your last number minus your first number, okay? Displacement is your final x position minus your initial x position, okay? The final x position in this problem is x at 7. The initial position is x at 0. So this will be 70 minus 0, which is 70. Okay, so you guys have done all of this before. Okay, you're going to get a very similar problem on your test, and I'm going to ask you to do it again. All right? Now, there's only one other thing on your test that I'm going to cover with you guys, and that's going to be the derivatives number. Okay, so number 10. So let's go ahead and do number 10 together too. Okay, you guys have a table right there in front of you. And I know I'm going to do this with you, and I'm going to warn you, when I do things with you, a lot of times what happens is you don't go do it by yourself, okay? But I'm going to encourage you to do it by yourself because this will be an easy A, and it'll be an easy 100 for this problem, okay, perfect score, if you do this by yourself, because you already know how to do this. So let's go ahead and look at letter A. We have f of x plus g of x, okay, when x is equal to 3, okay? What I'm asking you to do is find the derivative of this, okay? The derivative of f of x plus g of x is just f of, the derivative of f of x plus the derivative of g of x. But it says do it when x is equal to 3. So what you're going to do is everywhere you see an x, you're going to put in a 3, okay? And do I know what f prime of 3 is? What did you guys get for f prime of 3 on your chart? Pi. And then what's g prime of 3? Is it 5? And guys, this is it. Like, you can't do anything with this. If they were multiplied, you'd say 5 pi. But this isn't multiplication. It's addition. So this is about as far as you can go. All right? Let's look at letter B. Letter B, I'm asking you to take the derivative of f of g of x. Guys, if I'm asking you to take the derivative of f of g of x, what rule am I really trying to figure out if you know? The chain rule. This is equal to the derivative of the outside. Leave the inside alone. Leave it alone. Then multiply this answer, whatever this is, multiply this big thing by the derivative of the inside. That is a chain rule. You should have this memorized, okay? If you don't have it memorized, memorize it now. That is a chain rule. The derivative of the outside times the derivative of the inside, if you want to take the derivative of a composite function, okay? But I really don't want the derivative of x. I want the derivative at 2, right? So everywhere there's an x, I'm going to replace that with a 2, okay? Let me just tell you right now, the number one wrong thing students do, and I don't know why they do this, but for some reason they stick a 2 in here. They'll stick a 2 in here. Then they'll say it's f prime of 2 times g of 2 times g prime of 2, which I'm just letting you know is totally wrong. Okay, do not stick another x in here. All right, if you know the formula, it's not f of x, g of x. It's just f prime of g of x. All right, then you go to your table. What is g of 2? What is g of 2? Did you get it? 3. What's g prime of 2? -4, okay. So now you have to do it again. You have to go back to your table because all you did was fill in this number here. So you got f prime of 3. So now what's f prime of 3? Go back to your table. What'd you guys get? Okay, I'm not going to do this for you guys. So if you guys, I might just leave you guys here. What'd you get for f prime of 3? Pi times what? -4. Guys, what's pi times -4? -4 pi. All right, let's look at C. So C is F times G. Okay, guess what we're trying to get you to tell me? The product rule. Okay, C is F of X times G of X. Okay, if I take the derivative of this, okay, then this will be the derivative of the first. Myra, can you put your camera on? Times the second plus the derivative of the second times the first. Okay, derivative of the first times the second plus derivative of the second times the first. And what number am I going to plug in for this one? 3. Okay, so everywhere there's an x, I'm going to plug in 3. So times g of 3 plus g prime of 3 times f of 3. Okay, PEMDAS, right, guys? Multiplication before addition. So make sure you multiply these two together and then add it with multiplying these two together. Okay, go look up f prime of 3. What'd you get for f prime of 3? Pi. What's g of 3? -6. So the left side I have -6 pi. You guys good with that? Did we get the same things? On the right side, guys, what's g prime of 3? 5. And what's, I think that's f of 3. What's f of 3? 1. Okay, so on the right side I have 5. Did you get -6 pi plus 5? Check, okay? And you can't really simplify that anymore. So we are done. All right, and finally, your favorite one, the quotient rule. Okay, so let's go ahead and do D. D is f of x over g of x, where x is equal to 2. Okay, guys, what is the derivative of a quotient? And let me just tell you, the number one wrong answer is f prime of x divided by g prime of x. Okay. You can't just do that for derivatives. You can for limits. Okay, limits you can do that. But for derivatives, you have to say it's the derivative of the first times the second. Is this bringing back some good memories? Minus the derivative of the second times the first. But don't forget, all divided by what? The whole bottom squared. Okay, we're doing the quotient rule. Okay, now what number are we plugging in for x here, guys? Is it 2? Okay, so this will be 2, this will be 2, this will be 2, this will be 2, and this will be 2. And I know I have different colors, so mine looks better when I put a 2 on there. Okay, so then you're going to go to your table and grab all of these different numbers. So f prime of 2, I'm getting is 3/5 times g of 2, I'm getting 3, minus g prime of 2. Okay, guys, please tell me if I'm getting something wrong. So I'm just pulling this off of my table here. G prime of 2, I'm getting -4 times f of 2 is 6 all over g of 2, which I'm getting as 3, but I need to square that. So that's going to be 9. Okay, so if I simplify this, I'll have 9/5 plus 24. Well, this is a fraction, right? So you multiply, you have to change that to a fraction. This is what I get, and you're probably going to need to, let's simplify this, okay? This will be, get a common denominator of 5, okay, on the top here. So if I multiply 24, hey, wait, you guys have a calculator anyway, right? Okay, so what if I do 9, would it become a decimal though? Oh, it will, okay. So it'd be 9. I'm okay with it, but I think I'm okay if you leave it at a decimal, but I think it's nice if you know how to do fractions. Can you frac it again? You know how you do that frac thing? Math, frac. Does it even give you a number? Oh yeah, 43 over 15. Oh, really? Oh, yeah, that's cool. Okay, wait, I've never done that. Okay, so you can actually do that.
Yeah, if you do alpha y equals, it turns it when you hit enter, it makes it a fraction instantly.
Oh, it
Instead of doing
does?
decimal. Yeah. It's
Oh,
really
so
nice.
automatically makes it a fraction. Oh, that's kind
Yeah,
of cool.
you can also do that in the numerator as well. If you do alpha y equals again in the numerator.
Oh,
better.
okay. But wait,
And then also you can
but that didn't make it a fraction.
If you have non-frac like 9 over 5, if you don't make that a fraction with alpha y
Oh,
equals,
I
it
see what you're
won't do
saying.
it.
Okay, so do this and then do another one inside it.
Yeah,
Oh, I see. Okay, and then
like layers.
do another one
Sure.
inside it. So alpha y again. Okay, and then do 9/5 here, and
Yeah.
then plus 24. Whoa, Troquet taught you guys that? That's pretty cool. Okay.
My brother taught me that.
Oh, that's pretty
Yeah.
cool. I did not know we could do that. Okay.
There's also, if you do alpha y equals, I think you hit the down arrow once.
When you did the
You can
frac one?
do,
Oh, it just gave you a decimal. Oh, your calculate, you must have paid more for yours. Yeah.
if you do alpha y equals and you go down one, it gives you the complex functions. You can do like,
go over to.
Go
yeah,
over to numbers.
go back to the menu.
Okay, Thomas is talking, thinking we're doing something different.
But what are you doing?
I was talking, there's just another way to do the alpha y equals when you go to math numbers and then it gives you the fraction.
Oh, really?
Yeah.
Okay.
Oh, there is.
Might be a
About that.
secret to that.
Okay. No, it's good. It's good. Oh, there it is right there. Okay. There's the other way to get it. Okay, got it. That's
Yeah,
kinda
the
cool.
bottom one, I think
Yeah.
the bottom or the one right above that is complex functions.
Oh, got it.
It's like
Okay.
got the little things at the side.
Oh, that's kind of
Cool.
cool. Okay, so those problems are on the test, so make sure you guys can do those problems. Those are your review problems, okay? So basically, we've done number 8, 9, 10 together. Not
Okay, we can do 9.
8, 9, 10. Yeah, we did. Number 9 was basically the notes. We did it. We did it. You probably missed it because you blinked. We did it with Thomas, because remember Thomas said he had to put the E in there, and we put the E in there. It's just a math 8, so you can do math 8. All right.
Yo, who's Thomas?
Oh, sorry, Andrew.
Oh, yeah.
The other Thomas. Sorry. Okay. Let's look at what questions you guys have. I'm going to pull 3 optimization problems from 1 through 7. Okay, and these are exact duplicates of your homework that you've had so far. Okay, so I would just look over these problems, make sure you can do all of these problems. You've done them already. Okay, I'm happy to do any problems with you guys that you want to do together. But 3 of them will be on your test. For sure, number 5 and 6, one of those rectangular boxes will be on your test, but I can't remember if it's an open top or a topless box. I can't remember, but one or the other. Make sure you know the formulas for both of them. Okay. On just talking about homework or just looking at this homework, this review, what questions did you guys get stuck on, or would you like to do together?
Number 3.
Okay, let's do number 3. We're talking about the review, right?
Yeah.
Okay, so let's look at number 3. This one is exactly like the paper one. Okay, really they work the same way. Okay, this is a flower garden. Okay, and what you have are margins in this flower garden, but these are borders instead. Okay, what do you want to call the dimensions of the flower garden? Okay, are you guys okay if the horizontal is X and the vertical is Y? Okay, so I'm going to call this X, this Y. Okay, now be careful. What happens is, well, let me just go ahead and put the margins here. This margin here from left to right is 2. Okay, this over here is 2, and the Y is going to be 1 and 1. Okay, that's the problem we're looking at, guys. Online, you guys might be looking at slightly different numbers, but the problem will be worked the same way. This is number 3 on your review. Okay, what a lot of students do wrong, just FYI, is they'll pull, like, I don't know if you see this, but this value here is the Y value here. Do you see that? They'll switch the X and the Y's, just FYI. So be very careful when you set up your minimum area, because you're trying to minimize, I think. You're trying to minimize the area, okay? Then minimize the area of this blue area. You're trying to minimize this blue area. When you try to minimize that area, make sure you're saying y plus 2, not x plus 2, times, and this is going to be x plus 4, not y plus 4. So a lot of times students mix up the x and the y, and then it goes nuts, okay? Ryan, are you with us? No, the other Ryan, sorry. Okay, so this is the area of this big blue area. We're going to minimize it. So if whatever you minimize, you take the derivative of it and set it equal to 0. Now, don't take the derivative of the wrong function, because there's two functions going on here, okay? What I want to do is get this in terms of only x or only y. So there's another function, there's another equation going on, okay? And what is the other equation on this problem? Do you see it? Very good. xy equals 100. All right, no, 114, right? 114. All right, solve for y or x, it doesn't matter. I'm going to go ahead and solve for y, okay? Then go plug that into this right equation over here. And that way it's going to kill one of my x's or kill one of my y's, which is exactly what I want to do, okay? All right, so we've got all x's there. What are you going to do next? What are you going to do next? I've got all x's. Yeah, I want to FOIL. I actually want to take the derivative of it, but I want to avoid product rule. So I'm going to go ahead and FOIL it. So I'm going to go ahead and multiply this first term by these two terms, and then multiply the 2 by these two terms. Okay, so what I get is the area is equal to 114 over x times x, which is actually 114. Then 114 over x times 4, but that's really 4 over 1, right? So that's going to be 114 times 4. Can someone tell me what that is? What is it? 456. Okay, 456 divided by x. All right, now I'm going to multiply 2 times x, so that's plus 2x, and multiply 2 times 4, that's plus 8. Okay, now I need to take the derivative. Are you guys okay if I rewrite before I take the derivative? Okay, you can take the derivative, but it's a little bit hard right here. So I'm going to rewrite it to 114 plus 8, which I believe is 122 if I'm adding that right, plus 456 x to the negative 1 plus 2x. Okay, I'm in a good place now. I've rewritten this, but don't forget to zip your pants, okay? We've done so much work. We think we've done the calculus, but do you see we haven't done the calculus yet? Okay, so make sure you take the derivative of both sides. The derivative of a is just a prime. The derivative of 122 is what? 0. Good. The derivative of 456 x to the negative 1 is negative 456 x to the negative 2, and the derivative of 2x is just 2. All right, now what do I do? You take the derivative and you set it equal to 0. So I'm going to take this, I'm going to set this equal to 0, I'm going to solve for x. When you solve for x here, what's going to happen? How in the world do I solve for x to the minus 2? That makes no sense. Cross multiply. So we're working with fractions here. You can't tell, but you are, because x to the minus 2 is really 1 over x squared, right? So what I get is 456, one fraction on the left, one fraction on the right, and an equal sign in the middle, okay? Make sure you're using real algebra though, not the fake stuff, okay? Then what you want to do is cross multiply. So I have 2x squared is equal to 456. Therefore, x squared is equal to 228. Let me know if that's wrong. And then I'm going to take the square root of both sides.
Is that the length or the width?
That's x, whatever you labeled as x, okay?
Yeah,
So, yeah, x is this long side right here. Yeah, when they say length or width, I don't know which one they want. So I always just put in one and then I'll switch it. Oh, but this is the horizontal. Do you see how it says horizontal is the length? Okay, so you know what I'm saying? Because the definition of length and width is not really defined. So this one says horizontal, so that's going to be your x. So x should be square root 228. How do I get my y, guys? Yeah, you just plug it in. And I think my math lab will be happy if you just leave it like that. If it's not, then you guys figure out what to do. It wants an exact answer, so it doesn't want you to put it in your calculator, for sure, okay? Did anyone do this already? Is my math lab happy if we just leave it like this? It is? Okay, good. Then we're good. All right. What other questions would you like to do? Yeah. Oh, okay, good question. For the flower garden, I think, see, what is the length, the horizontal dimension that will minimize the combined? For the flower garden, I think they just want the dimensions of the garden. So it's just the X and the Y, the inside. When they ask for the paper, I think they actually add the other two. Is that true or is that not right? Well, they're minimizing the garden and the border. Okay, that's what's being minimized, which we did minimize that. Okay, but the question is, what's the length right here? The question is, what's the length of the, it says, what is the length? What dimensions, okay, if you look at the very first paragraph, it says, what dimensions of the garden? So you want the dimensions of the garden. So it's the length of the garden, which is just your X. If you add 4 to it, I won't count it wrong, just FYI, okay? But for the flower garden one, I think they just want your X and your Y. For the paper one, they actually want you to add, you know, X plus 4 and Y plus 2. Yeah, X is this length, right? Well, I don't know if we call it width or length, but it's this line right here. That's X. Yeah, so L is the X and W is the Y, right? Does that make sense? Okay. No, but if you switch it, I don't care. Yeah, you'll be fine. I'm not going to be picky about that. Dude, that was not the hard part. The hard part was that. Okay. All right. Oh, you guys are wrapping up. We have at least 5 minutes, right? Okay, let's do another one. Okay. Yeah, let's do another one. So look at your homework. What other one would you like to do? Number 7. Okay. All right. So 7 is the cylinder. Okay. The hardest part about the cylinder, I think, is just memorizing the formula. Okay, so I'm going to look at number 7, which is the cylinder. Okay, it has a radius and it's an open top. Okay, it has an open top. All right, so that means it only has a base on the bottom. It doesn't have a lid. All right, I'm going to, let's see, we want to minimize or maximum. What are the dimensions of the lightest open top cylindrical can? When they're talking about weight, they are talking about surface area. It doesn't seem like it, but it is, because they're saying use the least material that you can. Okay. All right. What is the formula for surface area of a cylinder? Ryan, are you still with us? Okay. You're gonna what? Oh, well, why don't you just watch then? Okay. So if I want the surface area of the cylinder, it has no top, okay, then the surface area is going to be the area of the bottom, which is pi r squared, plus the area of this lateral side. So to get the lateral side, you cut the cylinder like that. Remember, you cut the cylinder, it becomes a rectangle. This height is this height. This length, right, this length is actually this length. Do you agree with that? So this length is actually what formula? 2 pi r. So the area of this rectangle is going to be just multiply length and width, basically 2 pi r h. Guys, if it had a top, how would this be different?
2 pi.
Yeah, you'd put a 2 right here if it had a top. Okay, but this one's topless. Okay. All right, so then what you're going to do is you're going to take the derivative of this, but then you're going to say, hark, the derivative, it has an r and an h. I don't want to do that. Okay. And so you're going to say, how do I get another equation with r's and h's? Do I have another equation with r's and h's? I know the volume is what? 125, but that's not an equation with r's and h's. What is an equation with r's and h's? What's the volume formula? Yeah, it's the area of the base, which is pi r squared times the height, okay? So guys, that's how you get the formula, the second formula, okay? You have a choice. You can solve for h or you can solve for r. Okay, how many of us want to solve for r? Nobody? Okay, we're going to solve for h. All right, so everybody sees that h is the easiest one to solve for. Okay, so you're going to take h, you're going to bring it over here, and you're going to put 125 over pi r squared. When you do that, 2 things cancel out. Do you see it? There are 2 things that cancel out. So I'm going to rewrite the surface area formula. Okay, but the pi cancels out and one of the r cancels out. So what I get is 250 over r. I know it seems almost too simple, but that's all you'll get. Okay, because the pi's cancel out, one of the r's cancel out, and I can multiply the 2 and the 2 and the 125. All right, what do I do next? Simplify it. Okay, how are you going to simplify it? Yeah, move that r to the top. Okay, and the reason is we're about to prepare to take the derivative. Okay, now don't forget, zip your pants, guys. Okay, sometimes we've done so much work, we forget to zip our pants, but we still have to take the derivative. So the derivative is 2 pi r minus 250 r to the minus 2. Can you do the derivative by yourself? Okay, I've taken the derivative. What do I do now? I've done the calculus. This must be the answer. Set it equal to 0. And guys, if you get this far, you'll get partial credit. And I'm going to make you go this far to get partial credit. If you don't set it equal to 0, I'll be like, you just took the derivative and didn't know what you're doing. Okay, set it equal to 0. If you go wrong from here, you'll get half credit. Okay, but you got to get it this far. All right, your goal now is actually to solve for r. You're trying to find your critical points is what you're doing. Okay, this r to the minus 2 means nothing to me. I have no idea what that means actually. Okay, so what you want to do is change it. How can I change it so it actually is meaningful? Yeah, move it to the bottom. Okay, now this is a lot more meaningful. I've got I've got 2 fractionals on the right, 1 fraction on the left. Hey, guess what I can do? I can get 1 fraction on the left, 1 fraction on the right. At least I can force it to a fraction, and an equal sign in the middle. And the cool thing about that is that I can cross multiply. Okay, once you cross multiply, okay, you could solve for r. Now be careful, you actually have to solve for r. Okay, so I get r is a cube root of 250 over 2 pi. And what a lot of students do wrong is they put this in the calculator and get the wrong answer. Do you remember why I told you students get the wrong answer? Because you need a parentheses on that 2 pi. Okay, but guys, you really don't need to put this into a calculator. Everybody understands that, right? So yeah. Oh yeah, you could totally do that. Then you won't have that 2 pi problem if you did that. Yeah, so Sadie is saying, can you change this? Yes, of course.
So why? Why can't we? I just plug it in and keep it all.
Yeah, I just leave it like that. But Sadie's seeing some simplification if she wanted to. Okay, then they're going to ask you for the dimensions. So you don't just need r, you also need h. Okay, so right here, where h is, wherever there's an r, I'm going to plug in my r. My r is this funky thing, and like I said, it is this giant thing. Okay, but that's okay. All right, just copy it, but don't forget to square it. Okay, because there's a square up here. Okay, you have to square your r, and this is the value of your h. I think on this one, do they want exact answer? So this should be okay. Okay, this is the exact answer. If you change it to a decimal, you guys understand that's no longer an exact answer. Okay, on your test, I don't care which one you do. Okay, you do it, and then I have both answers on my key, so whichever one you get is fine. If you do change it to a decimal though, please make sure you go 3 decimal places or it'll be counted wrong. Okay, so go at least 3. All right, you want me to set up another one for you? Or are you guys good?
I mean, I asked you to solve for h, but that's easy too. So.
Oh, it asked you to solve for which one? Surface
wait,
area?
You did solve for h. Sorry.
Oh, okay, yeah, I did solve for h. But on your test, I think I'm going to also ask you for surface area. Okay, so if I asked you for surface area, how would you get it?
Plug it in that equation.
Yeah, you would plug it into this equation.
Ooh, that was tough.
Okay, well, it'll be a little easier on your test. You'll see. Okay. All right. What other questions? Do you want me to set up any other one for you, or do you feel like
4?
you're good? 4? Yeah, let's set up 4. Okay. 4 is really a lot like the flower garden problem. Okay. It's a paper with margins. Inside here, you have X and Y, just like you do with your flower garden. But they define the Y and X a little bit differently from what I would like to, but that's okay. I'm going to keep it with what they do. They're calling the vertical side X, and this would be 4, and this would be 4. And your Y, this margin is 1, and this margin is 1. Okay, so in order to minimize my amount of paper used, okay, I'm actually going to minimize area. Almost always, if they're saying minimize an amount or a weight, it's minimizing area. The area of this paper, make sure you understand, and let me get my X's and Y's completely right. This is X plus 8 times Y plus 2. Okay, a handful of students every year mix up the X and the Y, and I can see why you would do that. Okay, I need another formula, just like the flower problem. This other formula, is it 16, right? The area is 16. Okay, you solve for the X or the Y, whichever one you want. I like to solve for the Y, because if you solve for the Y, then everything on the right side becomes in terms of X. Okay, when you plug in your Y. All right. What do I do next? Take the derivative, right? You guys want to FOIL, or do you want to just go ahead and do product rule? Okay, I think foiling is, if we're consistent, so I'm going to multiply x times these two terms, multiply 8 times these two terms. I'll get 16 plus 2x. When I multiply 8 times 16, I get a headache. No, actually what I get is 108. No, actually I don't know what that is. Oh, 128, thank you. 128 over x plus 16. Okay, take the derivative of this, and it's just like the flower garden problem. Okay.